When you click on connection, this is the page which will appear to you whenever you open IDEA StatiCa. Here you have lot of options. You have to click on connections because this is what we are going to use IDEA StatiCa for designing our connections. So click on connection. It will take some time and this window will appear to you. A new file will open. Right now it is untitled. Here you have lot of options. So let us see. First, what we will do. Here you have one class. Here you have various type of connections. First one you have beam column connection. Second you have beam to beam connection. Third you have connection with gusset plate. Next one you have base plate connection, and finally you have this 3D type of connection. Okay, you can use any of the type of connection you want. Today we are going to discuss the base plate connection. So let me click on base plate connection. Again in type 2 topology, here you have various kind of base plate connection. First one is with I section. Second one is again with I section but an additional circular member. Third one is with a hollow square section. Fourth one is with a hollow circular section. So you have various kind of sections. We are having, if you see my model, I am having a member which is I section, ISMB 200. So I can click on the I section. Again in step 3, if you see, here you have two options, moment connection and shear connection. In moment connection you have two options. One is a simple one. In second one you have some additional stiffeners. Next one is the shear connection. Okay, and in 4 parameters, here you have to enter your details of your project. Okay, so this is the interface of your software. But let me tell you, why do we prefer IDEA StatiCa? If you see, we are using StatPro software, which is a software by Bentley Systems. So Bentley System has this software StatPro. Generally, the industry uses this software to design the members. Whenever you want to design your steel member, you will use StatPro. And whenever you want to design the connections between these members, you will use IDEA StatiCa. There are n number of softwares available in the market, but these are the mostly used in the industry. You also have another software which is a part of Bentley system, which is called RAM connections. We can also use RAM connections, but in this course we are going to cover IDEA StatiCa because IDEA StatiCa is more user friendly and it is more simplistic, and nowadays more and more adaptation of IDEA StatiCa is going on in the industry. And RAM connection is also a good software, but the problem is with its interface. The interface is not very user friendly and you don't have most of the templates available. You have to prepare from zero in RAM. So most of the people don't prefer RAM and they prefer this IDEA StatiCa because here, based on the type of connection you already have many of the templates available. So these templates you can directly use and design your connection. Even if you go for beam column connection, you have n number of templates available for each type of your connection. Again, beam to beam connection, again you have many type of connections. So this is the advantage of IDEA StatiCa, where you have ready-made templates depending on type of your connection. Okay, so we are going to go with I section. We are having a base plate. First, we will go with shear connection. Yesterday we had discussed when we go for shear connection and when we go for moment connection. When you are having a pin support, maybe explain you this. The advantage here, you have a lot of templates. Okay, now we are going with base plate connection. Whenever you are having pin support, you can go with shear connection. And whenever you are having fixed support, you have to go with moment connection. Okay, this right now, first we will go with pin connection. So I am choosing shear connection. Here I have to give name, pin support. This is simple. Here you have to choose your grade of steel. Again, one more thing. There is one problem with IDEA StatiCa. Whenever you are designing base plate, whenever you are designing any connection which is connected finally to the concrete. So in this case, whenever you are designing base plate, the design code what you can use, here you have various options to use the design code from European, American, Canadian, Australian, Russian, Chinese, Indian, and I think this is Hong Kong. But whenever you're designing for member connection, maybe our steel to steel connection, you can always go with Indian code. But whenever you are designing any connection which is finally connected to the concrete, in this case, whenever you are designing your base plate, you have to go with European code, because whenever you use Indian code, this is not feasible with the software. So you have to go with European code whenever you are designing base plates. Okay, here you have to choose all your material. So steel grade, because we are going with base plate connection, I will go with European, and steel grades will also be as per European. So let us choose. We are having E250, we do not have any equivalent European code, so let us go with maybe a smaller one, so S235. Yes, click on OK. And bolt assembly, you can just choose any. Right now, whatever is the default bolt assembly, I will choosing that. M16 8.8 grade, concrete grade, C20 35 25 30. Okay, and design code. Once you enter all these details, just click on create project. See, this option is available to you. Whatever template you have chosen, that template is available over here. It can be seen over here. Okay. Now let us understand what are these things. This is the window where whatever modeling we will do, that would be seen. Okay. Here you have some options. Here you can maybe rotate the member, see the member from top, or if you click on home, you will get the original view. Now you can see in this, here you have three options: member, load effect, and operation. So let us understand each operation one by one. First, you have member. Right now we are having only one member in our system, that is the column. So here it's written column, COL. Okay, and you can see a dash below this. So this is the bearing member. Okay, right now we are having only one member, so this bearing member is not important. So just try to understand that this is your member column, and here you have all the properties related to your member. Like in properties, you have the cross section. By default, it has taken HEB 300. This is some European cross section, but we are having, if you go in our design, okay, this is fixed connection. First, let me make this pin connection. So what I will do, go in supports, create pin connection, add, choose the pin connection, go in view, front view, and choose all the nodes. Assign to selected node, assign, yes. And just let me run this model, because first I want to do with pin connection. Okay, just click on done, go in post processing. Okay, go in reactions, go in envelope, copy all the reactions, control C, copy them, go in the Excel, go in support. From here you just paste your values. Because I am having pin connection, so moment would be 0. Okay, this we will use later on. Let's go back to our IDEA StatiCa. Okay, so what I was telling, let us see what is this member. If you double click on this member, we are having ISMB 200. So go back to your model. Here you have the option, only one option, HEB 300. So click on this edit parameter. Once you click on edit parameter, here you can choose your shape. So click on these three dots. Here you will have a lot of shapes available. We want to go with Indian, so drag down until you find the Indian code. I think this is it. MB IS808. So I am having ISMB 200. So choose ISMB 200 and click on OK. So this is the column what you are having. Okay, material is chosen over here. We are having E250, but that material is not available over here. You can see after S235 you are directly having 275. So let us go with a lower grade of material. In actual we are having E250, but because that is not available over here, we are going with a lower one. Because whenever we are going for base plate connection, we go with European code. This is the disadvantage of IDEA StatiCa. Whenever you are designing base plate, you go with European code, because right now IDEA StatiCa is not compatible with Indian codes for base plate design only. Whenever you are designing member design, member connections, during that time you can go with Indian code. So let's click OK. So now I am having ISMB. Yes. Mirror y z, this is not important. Geometrical type ended, this is fine. Position, here you can choose all the different types. Right now whatever is there, that is fine for us. So whenever we require these changes to be done, during that time we will understand them in detail. Next, after member, you have the option load effects. Here you have to enter the load LE1. So first load case. So here you have to enter your loads. Okay, one thing I wanted to tell you, if I go in this LCS, if I click on this, I think we should see the axis, the local axis XYZ of the member. These axis and the axis what we have in STAD, they are not the same because they are prepared by different companies. This software is prepared by Bentley Stad Pro, where you have y-axis upward, and this IDEA Statica is prepared by some other company where you have x upward. But don't worry, I have given the solution over here. You can see this is my Excel, which we are going to use to take the load from Excel to our IDEA Statica. So here I have global axis in Stad Pro, fx, fy, fz, mx, my, mz. Similar axes in IDEA Statica are here. Global axis in IDEA Statica, Vy, Fx is Vy, Fy is N, Fz is Vz, and My, Mx, Mz. Okay. So we have to enter these values in our model. So go in your model. N, first is N. So what is N in my case? 23.568. So I'll just go in this, and here I will type 23.568. That's it. Vy, if you see, Vy is 6.56. So I will type 6.56. Vz is 6.134. Vz. So I'll type 6.134. Okay. Mx, My, Mz are 0 because I'm having pin connection. If you zoom over here, you can see this is going upward, but I'm having compression in my member, so this will be with a negative sign. Okay, downward. Then I am having shear force in these two directions, 6.6 and 6.1, and this is 23.6. Okay, this is correct. This is related to load case. So I am directly taking the maximum load case which is available. What about negative? See here, whatever values are seen, those values are as per our Stad Pro. Okay, so this is my Stad Pro values. So you can see here I am getting positive value. So this means this is compression in my member. So here it should be downward because, okay, let me maybe explain you this thing. I will take a screenshot. This is from IDEA Statica, and these values, if you go in post processing, if you go in reaction, these values are reaction. So okay, let me take it in this way only. These values what you can see, those are reaction, and these are forces in your member. Okay, let me explain this. So this is my column, and in this column I am having these reactions. Is it clear? Upward force and these two direction of forces, and similarly moment. But right now because I am not having moment, so it is easier for me. Okay, and you can see here it's written x, y, and z. If x value is negative, so if you see the axis also, global axis, this is my global axis. So I should have taken the complete screenshot. Yeah. The first value, if you see, if, for example, of this, let us take the central column, 0.327. Okay, let me maybe mark it. What we are considering, we are considering these values. We have 0.2327 in x direction. So this value is 0.327. Y is 23.563. 23.563. And your Z value is minus 0.001. So maybe it is in this direction, 0.001. Right? This is the reaction forces whatever I am having. But when we are applying these forces in idea statica, what we are applying, if this is my column, I am not applying the reaction, I am not taking the reaction whatever I am getting, but I am applying the forces in this. So this direction of force and these things, so these are action, I can call them as action. So it would be like this, okay, opposite to what is shown over here. In reaction, okay, this maybe I will minus 0.001. So these values, action forces, of course they will be negative 0.001, 0.327, 23.563. So these are the action what we are applying from the reaction what we are getting in StatPro. This is the action what we are applying. So I will just write this thing. This is reaction forces, and this is action. I hope it is clear. But one more thing, this example what I showed you, this was only particular to this column. But in our Excel, what we are getting directly the maximum forces comparing all the supports. So here we are getting directly the maximum forces, not only of one combination, not only of one load case, but all in general. Here what you can see in this picture, that is only related to combination number of 101. If I change this combination number, the values will also change. If I change this combination number, these values will also change, right? But in envelope, we are taking the overall maximum values. And in my Excel, these are calculated. So overall maximum values are this. So I will design my connection so that it will carry these forces. That's why we are having this downward force and these 6.1, 6.6. Okay. Load effect is done. Next, we have operations. In operations, we have n number of operations, many operations which are available, and we are going to discuss. If you click on, if this is operation, if you right click on operation, and if you click on new operation, here you can see there are n number of operations. We are going to discuss each and every operation in detail later on, but now let's focus on the template what we have. BP1, base plate 1. If you click on this base plate 1, this is the by default what you get. Member, material, thickness 20. So you can change this thickness. Let us change the thickness to 10 mm, or maybe first we will go with 20, whatever is the default. Here you have offset 20, 10. If let's make 0 and see what is this offset. Okay, so I understand now. This offset is the offset of my base plate. If I write here 50, then this will go 50 mm additional to my column. If this also I write 50, it will again go 50 mm. Okay, these all things is fine. Anchor, here you can choose your anchor. Anchoring length 400. Let me change this to 200. You can write any value you want, 200, 300. And here you have again anchor type straight. Okay, that is fine. Layer minus 90, minus 80. So let us make this 0 and 0 and understand what is this. Okay, so now I understand top layer and left layer, these are the distances between my bolts. And if I write 0, 0, they are going towards the end of the columns. If I write 50, they will go 50 mm outside the column. If I write minus 50, they will go 50 mm inside the column. Okay, and here also if I write 10, they will go 10 mm outside the column. If I want to see this properly, I will go in top view. Here I can see them. Okay, because I right now I'm going for pin connection, so I want my connections to be near the web. So maybe let's write this 0. This is better. Now next option you have welding. Okay, we are going by one all the options. First, when you click on operations base plate, first you have all the base plate detail. Next you have offset details related to base plate. Next you have details related to anchor. Next now you have details related to welding. So here you have flange weld and web weld. So both I will just reduce this to 6 mm, 6 mm and 6 mm. Here you can increase or decrease them. And again here you have various kind of options: fillet weld on left side, or fillet weld on right side, or welding on both side, or you have butt weld, or you have no welding. So I will go with welding on both the sides. Yes, this is related to weld. Now I have foundation block. Let me click home. Yes, foundation block offset 300. If I make this 0, then it becomes equal to my base plate. So I will make this 50 mm extra from my base plate. Depth 600. If I make 400, I can change this 300. If I am writing depth as 300, so anchor depth should be little less, maybe 200. Okay, and here you have shear force transfer through anchors. Because I am having anchor, I want my shear force to be transferred through anchor. Standoff direct. This is fine. So these all are trial and error. You have to enter some value and see what you are getting in your model, and try to change the values so that you get your desired output in the model. Okay, this is done. Now what I can simply do, once these all settings are done, okay, one thing what you need to understand, we are only designing the connections. We don't want to check the concrete because we are not designing the concrete part. We are only designing the connection part. So you have to go in code setup, click on code setup. Here you have concrete breakout resistance. This is done, none. Okay, this is fine. So click on OK. So concrete breakout resistance, this value should be none. Otherwise, this program will also check your concrete, because we don't want to check our concrete. We only want to check the anchors, the steel part. So click on, once you do all these things, just click on calculate. Your calculation is done. Here you will get the results. Analysis 100% done. Plate, it is also checked. Anchor, it is also checked. Utilization 4.5. Welding done. Utilization 6.4. Concrete block done. Utilization 3.1. Buckling not required. Yes, this is the check which is done, and you have your model which is ready. Now this, for the given forces, the operations what you are performed, they are enough, and this connection is safe. So we have done our pin connection. What we will do now, you can see everything is in gray color. Okay, let me explain you the color system also. Now what I will do, thickness, I will change to 10 mm. Again, I will calculate. Maybe let's change thickness to 5 mm. You can see some changes. So practical is 10 mm. Okay, let us change the anchor type. Click on plus. When you click on plus, here you will get all the options. So I will go with the lowest grade 4.6, M12 4.6. Click OK. So now I am having smaller bolts. If I click on calculate, the calculation is done. Now the utilization is increased. Okay, this is the maximum what we can go. Let me explain you the color system. If you get gray color, you have three color system and red. Gray, it means that it is not utilized. Green system means properly utilized, and red color means overutilized, means this is failure. You can see this as underutilized. This is pass, and this is also pass. If gray color appears, it is okay in design, you do not have any problem. But this is only telling that it is underutilized. It means there is no proper utilization. Green is good, and red is of course not allowed, failure. Okay, now right now we are having a normal connection, so it is underutilized, but we do not have any other option. This is the minimum what we are giving. We do not have any bolt which is smaller than M12 4.6 grade. So this is fine, and all the things we are getting correct. Okay. Now what we will do, we will go with next type of connection which is fixed. Okay, so this is my model. Now, for example, if I am having a fixed connection, so go in support, view, front view. Let's choose the connections, assign, yes. Let's try with fixed support. So analysis and design, run analysis. Post processing, okay. Reactions, envelope, choose all the values, copy, go to Excel and paste it. Okay, now these are the values related to fixed support. Okay, this is for the pin. Okay, so what we will do now, if you are having a similar kind of connection, you can just click on copy. If you click on copy, similar kind of connection is created and a copy of that is created. And if you drop down, you can see here your first connection. This is your second connection, the copy what is created. If you want to change the name, go in project, pinned support 1. So choose this and write fixed support. Okay, go back, click on save. Okay, I want to save this base plate warehouse 1. Okay, you have to give some name and save it. Now I have two support. First one is pinned support. The analysis is done. Perfect. Second one is my fixed support. This is not yet done. So what column? Column will be same. Load effect. This load effect will be different. So I will change these values. N I have 23.566 minus 23.566. Vy is 7.418. 7.418. Vz is 6.858. 6.858. Mx is 8.806. 8.806. My 0.000. 0.005. And mz is 10.911. 10.911. This value is very zero. You can maybe just write as 0. This is also fine. Try to understand what are these values. Let me show you first pinned. See, in pin what we have axial force in the column, shear force in minor direction, shear force in major direction. Even when you change the sign, the result would be same, right? Now if you see the fixed condition, these are the values for axial force, shear forces, and these all three values are for moment. See, if you use your right hand thumb rule and if you are pointing your finger in this direction, okay, for simplicity, Vy, so I will temporarily write these values as 0, mz and mz. See, now if you place your thumb in this direction, 7.4, you can see your fingers which are similar to the value what we have written over here, right? The value is very small, 0.005, but you can see the finger and your thumb, they are going correctly, the shear force and moment. So no need to change sign. And what was this value? Can I do back, undo? Can I do undo? No. Okay, well, let me check. This was 6.85. Now you have the value in this direction, thumb, and the moment is also matching. In Excel, if I see mx, I'm having 8 point. Okay, something is wrong. Mx in IDEA StatiCa my, it is 8.806. So my is 8.806 and mx is 0. This was wrong. Thank you for clearing it. Yes, I don't have any torsion in my member, but I'm having bending in these two directions. If I want to write mx 0.005, 0.005. Next, after loading, if you have any question, you can type. I will try to answer it. Next, we have base plate. Now let's change the base plate. What we will do? We will change this now because we are having fixed connection. The supporting the anchor should be outside the flange as well. So what I will do? Now see, this is interesting. Minus 50 slash 50 slash 75. I'm seeing from top view. See what I did, minus 50 was already there. After that, I write 50. Then I get this. I understand, okay, I want it at a further distance 75. So now I am getting 8 bolts. I am writing minus 50 and 75. So in minus 50, I am having these 2 bolts, and in 75, again these 2 bolts. This thing you have to do it with trial and error. Okay. And this, what I will do, similar to 6 mm. Okay. And all remaining things are fine. Only thing what I changed my anchoring. Now let us try and see if it's working. Home. Yeah. You can see my anchors are not working. So what I can do, I will increase my anchor type. So I will go with 8.8, the heavier one, and instead of M16 I want M12. So click on plus, 8.8 grade M12. Click OK. I just increased the grade. Again click on calculate. Now this is working with very higher utilization, 90, 99, 88. Increase the length of anchor. Yes, that also can be done. Anchoring length, let me take 250, and this I will go depth of footing to 400. Let's try now. Utilization has slightly changed, but I think this is not affecting. Even 200 is fine. Weld portion is not in red color, but it is in orange color. Again, let me take screenshot and explain you. Okay, we have come across one more color. If you go in notes, here I think we should write one more thing. What I will do, I will choose these things and bring it down. Here we also have orange. This is also pass. This is number 3, and this you have. If you are having gray color, it means it is not utilized. Green color is proper utilized. Orange color, it is near failure, fully utilized, but still it is okay because it is passing. And finally red, which will be overutilized, which is failure. You can see in the figure, you have some gray color which is not utilized. You have some green color which is properly utilized. You have some welding which is orange color, that is fully utilized. And if you have anything in red, that is failure. Now one more thing what I will do, maybe I will just write 50. It is going outside the plate. Maybe I'll write 25, and this also I will write 25. In this case, now what I am doing, I am having only 4 bolts which are outside the web and flanges at these corners. Let us try and see what will we get in this case. Okay, it's not working. So what I will do, maybe let's do this 0 and 0. Okay, 100. Okay, minus 100. If I write minus 100, I am only getting 1 bolt at the center. And now I will write 50, 75, 100, 125, See, you have to do this trial, and maybe this I'll write 10 or 25. 25 I think is too much, 20 is good. Now if you see, I'm having 6 bolts instead of 8. Let's try with 6. Again click on calculate. Still not working. Okay, what I will do, this part is failing. See, this was 235. Let me just change this to 275. In actual it is 250, but I'm not having 250, so let's try 275. Base plate also 275, and let me take thickness as 20. Now it is heavier, and okay, it is passing. Let me change this to 10 and see. Welding is not passing. Everything is okay, but welding is not. Maybe 15. It's okay. So we can also go with 6 bolts, provided we go with base plate of thickness 15 mm and material is 250. This is fine. You have to do these kind of trial and error and try various kind of combinations to get your perfect answer. One thing what we understood, whenever you are having zero moment, that means whenever you are having a connection which is pin connection, then you can go with anchors only near the web. This is fine. But when you are having moment, which is in case of fixed support, you have to go with anchors outside the flange so that it will carry that moment. In that case, you have to go with this kind of thing. You don't have to do this for each support. This Excel you have, in this Excel, what I have done, I have already taken the maximum forces from all the support. So you don't have to do this for each and every support. Here, what values you are having, these are the maximum values in all your support. So in any ways, we are very conservative and we are only having one type of base plate for all the columns. So let me show you. This is my stat file. So what I will do now, okay, why it got hung? View display, yes. So all these supports will have the same base plate if I'm having fixed support. If I'm having pin support, all my base plate will have this same support.